Now, first and foremost, we have Meni Shmueli here with us. He's the co-founder and CEO of DataFlint. He previously worked on as a data and AI platform engineer at ZipRecruiter and as a big data performance researcher at Granulate. He's going to be talking about how to orchestrate Apache Spark with Airflow. So please, everybody, give him a kind hand of applause. And Meni, please take it away.
Cool?
Yeah, you're good.
Yeah, speak to the mic. Awesome. Hi, everybody. Really happy to be here. Just landed 2 hours ago from New York. And it's my first time in Austin, so I'm super excited. Today, I'll talk about orchestrating Spark with Airflow, focus about like the art form of big data and using Airflow, cost and performance. So a little about me. My name is Meni Shmueli. I'm the co-founder and CEO of DataFlint. So in the sentence, what we do, we are an AI co-pilot for Apache Spark, meaning we try to give AI models context about how your big data workload works and to be able to optimize, troubleshoot, and basically bring the revolution to big data, because in big data, really, like context is everything, and context about production is everything. And you really need to collect this context and present it to AI in a very concise way to be able to optimize performance and troubleshoot hard problems. So how Airflow's got anything to do with it? So somehow 99% of our humanity big data efforts runs on Airflow plus Spark. What does it mean? Airflow is the orchestration layer, is the part that tells what to do and when and in which order. And Apache Spark is the execution engine, meaning we need to process terabytes or petabytes of data and do that on hundreds of machines. This is where Spark goes in. Both of them are open source projects used for like most of Fortune 500 for most processing of data. In general, in the world, there are like tens of billions of dollars of resources and all of humanity big data efforts and data collection being done with this. There is something new called Spark Declarative Pipeline, which moves part of the like ordering stuff to Spark. I won't touch on that today, but that exists. And basically, these two products together consist of like how big data works. And the funny thing here is that like each of them like lives in own sphere. And when you combine it together, like some interesting stuff happened about like how they work now to optimize it. So basically, Apache Airflow runs stuff and doesn't know what it runs. Apache Spark doing computation doesn't have any idea who runs it and why, in which order, and so on. So use case we saw in customers that, again, we collect the data and then try to help them optimize and troubleshoot. They have an Airflow DAG. Everything is green. It takes few hours. Everything completed successfully, but behind the scene, it's so super expensive and slow. Actually, it has like 5 steps. Each step is reading the data 5 times, the exact same data, and like it's super not efficient. Nobody notices. So we'll try to touch 3 questions regarding it today. The first one is which step is like belong, like from Airflow, figure out where is the issue. Second, in Airflow, should we run stuff in big data sequentially or or parallelize them, and why we should choose each one, what could be the issues. And finally, talk about a bit about resource usage in big data and how it relates to Airflow. And feel free to ask any question, like Becky, that it will be also like kind of a conversation, not like a formal lecture. So first about finding the most expensive step. So the thing about Airflow, because it's just running stuff, it doesn't know what it runs, like, or what it does. You see duration, like when you look at, like it takes 1 hour, 2 hours, but it could be like 1 hour for one machine or 1 hour for like 10,000 machines. And the important stuff is like not understand the duration, but understand the cost, because one step of Airflow that runs Spark could run hundreds of machines. So here really like the important stuff is figuring out in Airflow which steps like cost the most and focus on that. In this example, in this customer, like we anonymize the data, that's a screenshot from DataFlint, but from a very large workflow, like 73% of the cost was concentrated in 8 steps and 5 of them did the exact same. So that's the kind of things like really important to understand when we try to figure out like what's going on, like what we can do about it. So here's where is like investigating Sparks come in. So in this case, we saw in Spark that basically the job takes the same table, like source table of 5 billion rows, and read it 5 times and filter, like doing the same computation, read the data and filter it 5 times. And that's like really not efficient. And because of Airflow, it also did it 5 times because these steps was being called 5 times. So that's a classic big data issue. Why it happens? Because in big data, let's say we have 5 terabytes of data we need to read, but we also only have 1 terabytes of RAM, right? In big data, a lot of time we process terabytes or even petabytes of data. We don't have enough RAM to do this processing. So what we'll do, use the disk and do it partially, and like every time load the data and only save part of it. And that means that we want, like, if we need to read the data multiple times, we'll do that. We won't save like a cache. But that could be super not efficient. Like in this case, again, that's the context is that we're reading the data, like a lot of data, and then we are filtering and saving a small portion of it. The engine doesn't know about it, so it's just reading the data multiple times. But if you look backward and investigate it, you can actually tell the engine to cache the data and fix the issue. And this way, like we find the issue like from Airflow, like what is costly and what's the issue, and we go to Spark, do the investigation and fix the issue. So that was a first like concept of like just understanding when using Airflow with big data with like Apache Spark. In this example, like we need to understand the cost aspect. The second like aspect I want to touch, which what we do in Airflow, it's like a DAG, the direct acyclic graph. It says one to run where and like which part of the computation could be run in parallel and which one should run right after the other. Logically, you think, oh, if I run stuff in parallel, it will be faster, right? But in big data context, that actually could be like completely misunderstood and wrong. So in this example, a customer saw a workflow in Airflow that ran for 94 minutes. It's like you can see it in Airflow, like 2 jobs like dictate like the critical path. There dictate the duration. And they thought, oh, let's take these 2 jobs and let's parallelize them. Let's run it in parallel, and that will improve the performance. It will make it faster, maybe even cheaper, right? Because it's running on the same hardware, on the same, like maybe like somehow like because we run it in parallel, like it will utilize performance better. So that was his logic. And actually for this scenario, 2 things could happen. The first one is what actually happened in this customer, which is if we return to the previous example, let's say we are reading 1 terabyte of data and we have 1 terabyte of memory. So if we run it sequentially, everything is well, right? It's fit into memory, then we process it super fast, and everything goes well. But if we parallel it, because all the different jobs compete on the same resources, what will happen, like big data engines really optimize to use memory. So they start using disk, like if you need to store data, they'll like save every time like part of the like data to disk and fetch it. It's like super slow. So actually parallelizing stuff make it run much slower compared to just run it in parallel, like one after the other. And it's much more expensive because it's slower, so it takes more time on the same resources. So that's like a misunderstanding. Like it's making sense in Airflow that like if you parallelize stuff, it will run faster, but it's actually run much slower if you try to parallelize them. The other scenario that actually like could improve performance, but it's a bit risky, that if you have a job that for some reason, I'll touch in a second why, not using all the resources, let's say like you run these 2 steps in parallel and each of them is not efficient, so it's using only part of the CPU and memory. So in this case, actually like parallelizing stuff will make it better because we'll use the resources that the other jobs are not using. So a bit about how you use Airflow in Spark. So you can run a cluster per task. So if you have multiple tasks, each task is starting a new cluster and then finish it. It's like better for like understanding your usage. Like you can like, tune each cluster for its task. Issue is that it takes time to start a cluster and then terminate the cluster, so it's a lot of waste. Another option is to use one cluster for the entire workflow. So for each DAG, you start a new cluster and finish it in the end, and then you use like the same resources. So that's a bit better, but steps are will be competing with each other. Then we have like the problem at the end. And finally, we can use one huge cluster for all of our Airflow DAGs. The issue is that we need to manage the capacity there. It's like require a lot of planning, and it require a lot of like attribution to understand like in this huge cluster who is doing what and how much it costs. It's like much harder. Finally, let's talk about resource utilization, big data, and how it relates to Airflow. So if we look inside each step that is running Spark in Airflow, and we look at the resource users, this is something like that's basically like what we look in DataFlint. That's like data we collect and give us context to AI models. What a lot of time we see is that, like, let's say the core utilization is super low, like 20%, like 20% of the cores are actually doing anything in the job we gave him. Memory could be high, could be 100%. So why is this happening and how it's related to Airflow? So in this graph, you can see the queries that are being ran. In the upper graph, you can see in orange, like the amount of cores we gave the cluster, and in blue, the amount of cores actually being used. So you can see it's like much lower, like we gave it a lot of cores, and for some reason, it's not using like these resources. So why does it happen? So in this specific example, so we need to find the query that is having this issue. And then when we dive deeper, a lot of time we'll see that at the beginning, everything is parallelized correctly, but over time, one task is lingering, and like it's like all the other cores does nothing because of a thing called partition skew in big data. Basically, let's say we are processing data on countries, and we have small countries and big countries. So maybe the US will take to process the data 10 minutes, and a small country like Haiti will take 1 minute. And part of the art of big data is how to parallelize everything and make sense that it will work correctly. So that's the thing we try to do at DataFlint, like basically fix the problem from root. In this case, it's a join between a larger table and a smaller table. And if you work smartly, you can like partition the data and making sure that it will work correctly. So the best solution is just to fix the problem from root and making sure that the big data cluster, if we have 100 machines, will use all of it, like all the cores and all the memory. So that's one option. But the other one is that if we talk about here, that we can, like if it's not efficient, let's say we have one task lingering using one core, we basically could release all the other cores in memory and give it to another Airflow DAG. So in this case, it's not ideal, but we could, if we have a lot of like very inefficient steps, we can all combine it together in Airflow, send it together to a big data cluster, and it will use the resources better. But again, in DataFlint, we are like in favor of like actually fixing the problem. And if you fix the problem, if your big data jobs is super optimized, then each task will use all the resources you were given, and like it really needs as much resources it needs to do its job as best as it can, and then performance is usually much better sequentially. Finally, about like how to bridge the gap between Airflow and Spark, some tips that we are implementing in the product DataFlint, but we will also be happy to share in the community. First, it's really important to propagate the Airflow metadata to the lower layers. So if you run a step in Airflow, propagate the knowledge about which DAG ID, tag names, tags from Airflow to Spark. From Spark, propagate it to the machines you're using in AWS, like its EC2s, or in other cloud vendors, from there to your FinOps systems, so you can figure out for each Airflow DAG, for each steps, how much it actually costs, and use the resource knowledge and usage to like figure out where is the problem is. Then try to figure out like insights from your actual execution layer, what is happening is efficient or not, and based on that, make decision about your Airflow dagging. And finally, like really once you collect all of this context, bring it all to AI that like it can do like amazing optimization today. So like the hard job is to collect the data and enrich it and make it all organized. And then AI with the proper skills and knowledge can really do wonders. And finally, like DataFlint, we also have an open source called DataFlint. You can take a look. It's basically a better UI for Apache Spark than the base one. So for the Insight one, if you're using Apache Spark with or without Airflow, you could install DataFlint and will get more observability and insight into your Apache Spark workflow, and you can help it optimize. And the commercial version, we also understand the Airflow level and like help it optimize with AI. Awesome.